Hello, and welcome to this calm corner of curiosity. Together, we'll explore scientific ideas both vast and small, some familiar, others quietly strange. Whether you're tuning in for comfort, rest, or fascination, thank you for sharing this time. Leave a comment and let me know where you're listening from. It's always a joy to know how far these stories travel, through cities, across oceans, and beneath starlit skies. If you enjoy winding down to soft-spoken science, I invite you to subscribe. The universe has no shortage of mysteries, and we have all the time we need to explore them. Gravity has a funny way of being both utterly familiar and completely mysterious, doesn't it? Every morning when you roll out of bed, gravity is there to greet you, pulling you gently toward the floor. When you pour your tea, gravity guides each golden drop into your cup. When you look up at the moon hanging in the evening sky, gravity is the invisible string connecting you to that distant, glowing companion. And yet, for all its constant presence in our lives, gravity remains one of the most profound puzzles in all of science. Picture this. Right now, as you're listening to these words, you're traveling through space at about 67,000 miles per hour. That's Earth's speed as it orbits the sun, though you can't feel it because gravity keeps you snugly attached to our planet's surface. But it's not just Earth that's dancing through the cosmos. The moon is waltzing around Earth, Earth is spinning around the sun, and our entire solar system is gracefully sweeping through the Milky Way galaxy in an intricate celestial choreography that's been unfolding for over 4.5 billion years. What makes this cosmic dance so remarkably stable? Why doesn't the moon simply drift away into the darkness of space? Why don't the planets go careening off into the void or crash into the sun? The answer lies in the exquisite balance between motion and attraction, between the urge to fly away and the gentle tug that says stay close. It's a balance so precise, so perfectly calibrated, that it allowed life to flourish on our small blue world. Let's begin with a gentle thought experiment. Imagine you're holding a ball in your hand. When you release it, it falls toward the ground. This seems natural, obvious even, but why? What invisible force reaches up from the earth to pull that ball downward? For thousands of years, this question puzzled humanity's greatest thinkers. The ancient Greeks believed that objects fell because they were seeking their natural place in the universe. Heavy things, they reasoned, belonged at the center of the cosmos, while lighter things preferred to float upward toward the heavens. This explanation held sway for nearly 2 millennia, until a brilliant Italian named Galileo Galilei began dropping objects from towers and rolling balls down inclined planes in the early 1600s. What he discovered was revolutionary. All objects, regardless of their weight, fall at the same rate when air resistance is removed. A feather and a hammer dropped in a vacuum will hit the ground at exactly the same time. This was the first hint that gravity wasn't simply about heavy objects seeking their cosmic home, but something far more universal and elegant. But it was Isaac Newton, sitting in his garden in 1666, who truly began to unravel gravity's secrets. The story goes that he watched an apple fall from a tree, though whether it actually bonked him on the head is a matter of some debate. What's not debatable is the profound insight that followed. The same force that pulled the apple toward Earth might be the very same force that kept the moon in its orbit around our planet. This was a revolutionary idea. At the time, most people believed that earthly physics and celestial mechanics were entirely separate realms. The heavens were perfect, eternal, and governed by divine laws, while Earth was messy, changeable, and subject to entirely different rules. Newton's genius was recognizing that the universe operates under one set of laws, that the gravity pulling on your morning coffee is the same force orchestrating the grand ballet of planets and stars. Newton's law of universal gravitation is beautifully simple in its elegance. Every object in the universe attracts every other object with a force that depends on their masses, and the distance between them. The more massive an object, the stronger its gravitational pull. The farther apart two objects are, the weaker the attraction between them. It's a cosmic relationship that governs everything from the fall of autumn leaves to the formation of galaxies. But here's where it gets truly magical. Gravity isn't just about attraction, it's about balance. When Earth orbits the Sun, it's not simply being pulled inward by solar gravity. If that were the case, our planet would spiral into the Sun in a matter of months. Instead, Earth is moving sideways through space at just the right speed, so that as gravity pulls it toward the Sun, the curvature of its path matches the curvature of space around our star. It's falling toward the Sun continuously, but moving fast enough sideways that it keeps missing. Think of it like this. Imagine you're twirling a ball on a string above your head. The string provides the inward pull, just like gravity, while the ball's motion provides the outward tendency. As long as these forces are balanced, the ball traces a perfect circle. Speed it up, and the circle gets larger. Slow it down, and the circle shrinks. Stop the ball's sideways motion entirely, and it falls straight toward your hand. This delicate balance between attraction and motion is what creates the stable orbits we see throughout our solar system. It's why Mercury, closest to the Sun, races around its orbit in just 88 Earth days, while distant Pluto takes 248 years to complete a single lap. The closer you are to a massive object, the faster you must move to maintain a stable orbit. But the gravity ballet isn't a simple two-partner dance. Our solar system is more like a cosmic ballroom filled with dozens of dancers, each influencing the other's movements in subtle but important ways. The Moon doesn't just orbit Earth in a perfect ellipse, it wobbles slightly due to the Sun's gravitational influence. Earth's orbit isn't a perfect circle either. It's gently perturbed by the gravitational tugs of Jupiter, Venus, and the other planets. These gravitational interactions create what astronomers call orbital resonances, mathematical relationships between the periods of different orbiting bodies. For every 2 orbits that Neptune completes around the Sun, Pluto completes exactly 3. For every 4 orbits of Jupiter, Saturn completes almost exactly 1.5. These aren't coincidences, they're the natural result of gravitational choreography played out over millions of years. Sometimes these interactions can be protective. Jupiter, with its enormous mass, acts like a cosmic vacuum cleaner, capturing or deflecting many comets and asteroids that might otherwise threaten Earth. Other times, gravitational interactions can be disruptive. Every few thousand years, the gravitational dance between Earth and Venus nudges our planet's orbit just slightly, contributing to long-term climate cycles. The precision of this gravitational choreography is breathtaking. If Earth were just 5% closer to the Sun, our oceans would boil away. If we were 5% farther out, they would freeze solid. If the Moon were significantly closer, its gravitational pull would create tides hundreds of feet high, making complex life impossible. If it were much farther away, Earth would wobble chaotically on its axis, creating wild climate swings that would prevent stable ecosystems from developing. And yet here we are in what astronomers call the habitable zone, or sometimes more poetically, the Goldilocks zone, where conditions are not too hot, not too cold, but just right for liquid water and life as we know it. It's a position maintained by the gentle, constant pull of gravity, fine-tuned over billions of years of cosmic evolution. This gravitational ballet extends far beyond our solar system. Every star in our galaxy is engaged in its own complex dance, orbiting the galactic center in periods measured in hundreds of millions of years. Even galaxies themselves are dancing partners, slowly spiraling around each other under their mutual gravitational attraction. In about 4 billion years, our Milky Way will begin merging with the nearby Andromeda galaxy in a cosmic waltz that will take another few billion years to complete. What's perhaps most remarkable is that this entire cosmic choreography emerges from the simplest of rules. There's no cosmic conductor waving a baton, no celestial choreographer calling out the steps. Just mass, distance, and motion, following the elegant mathematical relationships that Newton discovered in his garden over 3 centuries ago. As you drift toward sleep tonight, imagine yourself as part of this grand celestial dance. Feel the gentle pull of Earth's gravity holding you close, keeping you safe and secure as our planet spins through the darkness. Know that the moon above is your faithful dancing partner, its gravitational embrace creating the tides that have shaped our world for billions of years. Sense the distant sun, even in the darkness, its massive presence governing the rhythm of our yearly journey through space. You are part of the gravity ballet, a dancer in the cosmic choreography that connects every atom in your body to every star in the sky. The calcium in your bones was forged in the heart of an ancient star, held together by gravity until that star's final explosive dance scattered its elements across the cosmos. The iron in your blood once danced in stellar cores under pressures and temperatures beyond imagination, waiting billions of years to find its way into your veins. Tonight, as you close your eyes and let sleep carry you away, remember that you're not just resting, you're participating in the universe's most ancient and beautiful performance. Gravity cradles you as surely as it cradles the planets, and in the morning, when you wake to see the sun climbing the sky, you'll witness another movement in the eternal dance that connects all things across the vastness of space and time. Sweet dreams, fellow dancer in the cosmic ballet. The universe is holding you close, and the dance goes on. Looking at this cosmic journey through the birth and evolution of galaxies, we now turn our attention to how these magnificent structures continue to dance through space, revealing the elegant choreography that governs not just galaxies, but all celestial bodies in their eternal waltz through the universe. The story of gravitational interaction begins long before galaxies themselves took shape. In those earliest moments after the Big Bang, when the universe was still a hot, dense soup of fundamental particles, gravity was already at work. It was the gentle sculptor, the patient architect, taking those tiny quantum fluctuations we mentioned earlier and slowly, methodically, turning them into the cosmic web that would eventually cradle billions of galaxies. But gravity's influence extends far beyond simply gathering matter together. Once galaxies began to form, gravity became the choreographer of an intricate dance that continues to this day. Every star within a galaxy, every planet orbiting those stars, every moon circling those planets, all move according to gravity's invisible hand. It's a dance so precise, so mathematically elegant, that we can predict the positions of celestial objects thousands of years into the future. Consider our own solar system for a moment. The Earth doesn't simply orbit the sun in a perfect circle, drawn by some mystical force. Instead, it follows an elliptical path, its speed varying as it moves closer to and farther from our star. This isn't random or chaotic. It's the result of a delicate balance between the Earth's forward momentum and the sun's gravitational pull. If the Earth moved too slowly, gravity would pull it inward toward the sun. If it moved too quickly, it would escape the sun's grasp entirely and drift off into the cold emptiness of space. This same principle governs the motion of entire galaxies. Just as planets orbit stars, galaxies orbit each other in great, sweeping arcs that can take billions of years to complete. The Milky Way and Andromeda, for instance, are not simply drifting toward each other randomly. They're engaged in a gravitational dance that began billions of years ago and will culminate in their eventual merger some 4 billion years from now. But perhaps the most beautiful aspect of this cosmic choreography is how it operates on multiple scales simultaneously. While galaxies dance around each other in their vast orbits, The stars within those galaxies are performing their own intricate ballet. In spiral galaxies like our Milky Way, stars don't orbit the galactic center in simple circles. Instead, they follow complex paths that weave them in and out of the spiral arms, like dancers moving through an ever-changing formation. These spiral arms themselves are not rigid structures, but rather waves of density that move through the galaxy like ripples on a cosmic pond. As stars orbit the galactic center, they periodically move into and out of these density waves, spending time in the bright spiral arms before moving into the quieter regions between them. It's during their time in the spiral arms that stars are most likely to encounter the gas and dust needed to form new stellar companions, making these regions the galaxy's most active nurseries. The gravitational forces at work here are staggeringly complex. Each star influences every other star. Each cloud of gas and dust contributes its own gravitational signature, and the invisible dark matter that permeates the galaxy adds its own mysterious influence to the cosmic dance. Yet somehow, out of this seemingly chaotic interplay of forces emerges the elegant structure we observe, the graceful spiral arms and the stable orbits that have persisted for billions of years. Even more remarkable is how this gravitational choreography has remained stable over such vast periods of time. The galaxy we see today looks much the same as it did when the first complex life was emerging on Earth, and it will likely look much the same long after our sun has exhausted its nuclear fuel and begun its final transformation into a white dwarf star. This stability isn't the result of some cosmic accident, but rather the inevitable outcome of gravity's patient, persistent influence. The dance extends beyond individual galaxies to encompass entire clusters and superclusters. These vast collections of galaxies, bound together by gravity across millions of light years, move through space in their own stately pavane. They approach each other, pass by in gravitational embrace, and sometimes merge in spectacular cosmic collisions that can trigger bursts of star formation and reshape entire galactic neighborhoods. What makes this gravitational ballet even more extraordinary is its mathematical precision. The same equations that describe the fall of an apple from a tree also govern the motion of galaxies across cosmic distances. Newton's law of universal gravitation, refined by Einstein's theory of general relativity, provides the mathematical language for this cosmic dance. Every twist and turn, every orbital resonance, every tidal interaction can be described with mathematical elegance that would make a poet weep. This mathematical beauty reveals itself in phenomena like orbital resonances, where the gravitational influences of multiple bodies create stable, repeating patterns. In our solar system, we see this in the relationship between Jupiter's moons, where some orbit exactly twice for every orbit of another, creating a gravitational harmony that has persisted for billions of years. Similar resonances exist between galaxies, creating stable configurations that can endure across cosmic time. The gravitational dance also creates what astronomers call tidal forces, the same phenomenon responsible for Earth's ocean tides, but operating on a galactic scale. When galaxies pass close to each other, these tidal forces can stretch and distort their shapes, creating the spectacular tidal tails and bridges we observe in colliding galaxy systems. Stars can be flung out in graceful streams that stretch across hundreds of thousands of light years like cosmic ribbons marking the passage of these galactic dancers. Perhaps most fascinating of all is how this gravitational choreography continues to evolve. The universe is not a static stage upon which this dance is performed, but rather an expanding theater where the very fabric of space-time is stretching. This expansion affects the gravitational dance in subtle but important ways, gradually weakening the bonds between distant galaxies and ensuring that only the most tightly bound systems will remain together in the far future. As we drift towards sleep, Listening to this tale of cosmic choreography, we might find comfort in knowing that we are part of this grand dance. Every atom in our bodies was forged in the nuclear furnaces of stars that themselves were born from the gravitational collapse of interstellar clouds. We are quite literally made of star stuff, participants in a cosmic ballet that has been unfolding for nearly 14 billion years. The gravitational forces that govern the motion of galaxies also govern the circulation of blood through our veins, the rhythm of our breathing, the gentle pull that keeps our feet planted firmly on the ground. We are not separate from this cosmic dance. We are part of it. Temporary arrangements of atoms and energy that have briefly organized themselves into consciousness, into the ability to contemplate and appreciate the very forces that created us. So as you settle into sleep tonight, remember that you are riding on a planet that is orbiting a star, in a galaxy that is dancing with its neighbors, in a universe that is expanding and evolving according to the same mathematical principles that have governed cosmic evolution since the beginning of time. You are part of the dance, a note in the cosmic symphony, a brushstroke in the ever-evolving masterpiece of creation. The gravitational ballet continues around us and through us, patient and persistent, elegant and eternal. And in the morning, when you wake, the dance will still be going on, just as it has for billions of years, just as it will for billions more. Sweet dreams, fellow dancers in the cosmic choreography. Welcome once more to the depths of space and time, where the cosmos continues its ancient dance, and every heartbeat carries the rhythm of stellar fusion. We've traced the universe from its earliest whispers to the grand formation of galactic cities, watched as gravity sculpted darkness into light, and witnessed the birth of the very elements that now flow through your veins. But our cosmic story is far from complete. Tonight, we drift deeper into the gravitational embrace that binds not just stars to galaxies, but planets to stars, moons to planets, and all matter to all other matter in an endless, elegant choreography. This is the gravity ballet, where celestial bodies move not in chaos, but in perfect mathematical harmony, each following the invisible threads that Newton first glimpsed and Einstein later revealed to be the very fabric of space-time itself. Picture this. Right now, as you rest in the quiet of your evening, you are part of this dance. The Earth beneath you spins at over 1,000 kilometers per hour, racing through space at 30 kilometers per second as it orbits our sun. The sun itself, along with our entire solar system, sweeps through the Milky Way at 220 kilometers per second, while our galaxy drifts through the cosmic web at 600 kilometers per second. And yet from your perspective, all is still, all is calm. This is the profound gentleness of gravity's choreography, so vast and smooth that we feel only peace within its embrace. But how did this cosmic ballet begin? How do planets learn their steps, and what keeps them dancing in such perfect time? The answer lies in a story that began nearly 5 billion years ago in a cloud of gas and dust that would one day become our solar system. Here, in the gentle collapse of matter, under its own gravitational pull, the first movements of our planetary dance were born. Imagine a slowly spinning cloud, vast beyond measure, composed mostly of hydrogen and helium left over from the Big Bang, but enriched with heavier elements forged in the hearts of dying stars. Carbon, oxygen, silicon, iron, all the ingredients needed not just for rocky worlds, but for life itself. This cloud, known as the solar nebula, was perfectly balanced between expansion and collapse, between the outward pressure of its own motion and the inward pull of gravity. Then something disturbed this balance. Perhaps a nearby star exploded in a supernova, sending shock waves rippling through space. Perhaps the gravitational influence of a passing stellar neighbor provided just the right nudge. Whatever the cause, gravity began to win. The cloud started to contract, and as it did, it began to spin faster, like an ice skater pulling in her arms. At the center of this contracting, spinning disk, matter began to accumulate. Pressure and temperature rose steadily, degree by degree, until nuclear fusion ignited and our sun was born. But this was only the beginning of the dance. In the flattened disk of material surrounding the newborn star, countless smaller gravitational stories were beginning to unfold. Here, in this swirling disk of dust and gas, the delicate process of planetary formation began. It started small, incredibly small, with microscopic grains of dust bumping into each other in the gentle turbulence of the nebula. Static electricity and weak gravitational forces caused these tiny particles to stick together, forming ever larger clumps. These clumps, no bigger than pebbles at first, continued to collide and merge, their own gravity growing stronger with each addition. As these planetary embryos grew, they began to clear their orbital paths, sweeping up the remaining dust and debris like cosmic vacuum cleaners. Some grew large enough to capture not just solid material, but the gases of the nebula itself, becoming the giant planets we know today. Others remained small and rocky, their gravitational influence too weak to hold on to the light elements that the solar wind was already beginning to blow away from the inner solar system. This process was not gentle. The early solar system was a violent place, with planetary embryos colliding at tremendous speeds, sometimes merging, sometimes shattering into fragments that would later reform. The scars of this chaotic period remain visible today in the cratered surfaces of moons and asteroids, in the tilted axis of Uranus, and in the backwards rotation of Venus. Yet from this apparent chaos emerged order. The same gravitational forces that drove these collisions also worked to stabilize the orbits of the survivors. Planets settled into resonances, their orbital periods synchronized in simple mathematical ratios that prevented future collisions. The asteroid belt between Mars and Jupiter represents material that never quite managed to form a planet, kept in perpetual discord by Jupiter's massive gravitational influence. And so the dance began in earnest. Each planet found its rhythm, its distance from the sun determined by the balance between gravitational attraction and orbital velocity. Move too slowly, and gravity pulls you inward toward the sun. Move too quickly, and you escape to the outer darkness. But find just the right speed, and you can dance forever in the same graceful orbit, year after year, century after century, for billions of years. This is Kepler's revelation, refined by Newton's mathematics and perfected by Einstein's insights into the nature of space and time. The planets don't orbit the sun because they're attached by invisible strings, but because they're following the straightest possible paths through curved space-time, like marbles rolling around the rim of a bowl. The sun's mass creates a depression in the fabric of reality itself, and the planets simply follow the geometry of this curved space. But the dance is more complex than a simple waltz between planet and star. Each world influences every other world, their gravitational fields overlapping and interfering in subtle ways. Jupiter's massive presence protects the inner planets from comets and asteroids, acting like a gravitational shepherd that keeps dangerous objects in the outer solar system. The moon's gravitational pull creates our tides, but also stabilizes Earth's axis, preventing the dramatic climate changes that would occur if our planet wobbled chaotically as it spins. Even more remarkably, these gravitational influences extend across vast distances and long periods of time. The planets engage in what astronomers call secular resonances, slow changes in their orbits that occur over millions of years. Mars's orbit becomes slightly more elliptical, then more circular, in a cycle that may influence the planet's climate and the possibility of life on its surface. Earth's orbit changes too, cycling between nearly circular and mildly elliptical over the course of 100,000 years, one of several factors that drive the ice ages. These orbital changes are so subtle that they're imperceptible on human timescales, yet they shape the long-term evolution of planetary climates and the conditions for life. It's as if the planets are engaged in a conversation that takes place over geological time, each world's gravitational voice contributing to a chorus that determines the fate of atmospheres, oceans, and perhaps even civilizations. The precision of this celestial mechanics is breathtaking. We can calculate exactly where Mars will be 1,000 years from now, or where it was when the pyramids were built. We can predict eclipses centuries in advance, and we do this using the same gravitational principles that govern the motion of falling apples and swinging pendulums. The cosmos operates according to laws so reliable that we can navigate spacecraft across billions of kilometers of space and arrive at our destination with perfect accuracy. Consider the Voyager spacecraft, launched in 1977 and now traveling through interstellar space. Their trajectories were calculated using gravitational assists from Jupiter and Saturn, a technique that uses each planet's motion to accelerate and redirect the spacecraft. Like a cosmic game of billiards, mission planners calculated exactly how each gravitational encounter would change the spacecraft's speed and direction, allowing these robotic explorers to visit multiple worlds with the fuel needed for just one. This gravitational choreography extends beyond our solar system to encompass the motion of stars within galaxies, galaxies within clusters, and clusters within the cosmic web itself. The same inverse square law that governs planetary orbits also explains why stars in the outer regions of galaxies move too quickly for the visible matter alone to hold them in place, leading to the discovery of dark matter. The same principles that keep the moon in orbit around Earth also govern the slow dance of galaxy clusters as they merge and evolve over cosmic time. Yet for all its vast scale and mathematical precision, gravity remains remarkably gentle in our daily experience. You can jump, and gravity patiently pulls you back down. You can throw a ball, and gravity curves its path in a perfect parabola. You can lie in bed, and gravity holds you softly against the Earth's surface, a constant, reassuring presence that asks nothing of you but simply keeps you grounded in the most literal sense. This gentleness is deceptive, though. Gravity is relentless, patient, and ultimately irresistible. It shapes the cosmic web, drives stellar evolution, and will ultimately determine the fate of the universe itself. Whether the cosmos continues expanding forever or eventually collapses back upon itself depends on the total gravitational pull of all the matter and energy it contains. In this sense, we are all participants in the gravity ballet, not just observers. Every atom in your body contributes its tiny gravitational pull to the cosmic dance. Your mass, however small, influences the orbit of the moon, the motion of the planets, and the expansion of the universe itself. The effect is vanishingly small, but it is real, connecting you intimately to the grand choreography of the cosmos. As you drift towards sleep tonight, carried by the Earth through its orbit around the sun, remember that you are dancing. You are part of a performance that began billions of years ago and will continue long after the last star has faded. The rhythm is slow, the movement's vast, but the dance is eternal, and gravity is both the music and the floor upon which this cosmic ballet unfolds. In the gentle pull that keeps you nestled in your bed, in the moon that pulls the tides and stabilizes our planet's seasons, in the sun that holds our world in its warm embrace, you can feel the universe itself reaching out to you, reminding you that nothing exists in isolation. Everything is connected, everything influences everything else, and the force that binds it all together is as gentle as a whisper and as powerful as the cosmos itself. So rest now, knowing that you are held not just by your bed or your chair, but by the very geometry of space-time, by the gravitational embrace of planets and stars, by the same force that lit the first stars and will guide the last planets in their orbits around dying suns. You are part of the dance, and the dance is part of you. And in this cosmic choreography, there is a peace that surpasses understanding, a harmony that encompasses all things, and a rhythm that will carry you gently into dreams. Looking at the gravity and planetary motion content we've established, let me continue with part 4 of The Gravity Ballet, How Planets Dance in Space. But gravity's choreography extends far beyond our familiar solar system. When we turn our gaze outward, beyond the comfortable boundaries of our cosmic neighborhood, we discover that gravity has been composing symphonies on scales so vast they challenge our very conception of what it means to dance through space. The same force that keeps your feet planted firmly on the ground is simultaneously orchestrating the movements of entire galaxies, galaxy clusters, and the very fabric of space-time itself. Consider for a moment the Milky Way, our galactic home. This spiral collection of hundreds of billions of stars isn't simply a static arrangement of lights scattered across the darkness. It's a dynamic, rotating structure where every star, including our own sun, follows its own orbital path around the galactic center. Our sun takes approximately 225 million years to complete one orbit around the galaxy's heart, carrying Earth and all the planets along for this cosmic journey. This means that since the dinosaurs first appeared on Earth, our solar system has completed less than one full orbit around the Milky Way. We are quite literally passengers on a galactic merry-go-round, spinning through space at speeds that would make any Earthbound carousel seem practically motionless. The center of our galaxy harbors a supermassive black hole, an object so dense and gravitationally powerful that it warps space-time around it like a cosmic whirlpool. This invisible giant, known as Sagittarius A star, contains the mass of roughly 4 million suns compressed into a space smaller than our solar system. The stars near the galactic center orbit this black hole at tremendous speeds, some completing their elliptical paths in just a few decades. These stellar dancers provide us with some of the most dramatic examples of gravity's influence, as they accelerate to significant fractions of the speed of light when they sweep closest to the black hole's event horizon. But even our entire galaxy is not immune to gravity's greater choreography. The Milky Way belongs to what astronomers call the local group, a collection of more than 50 galaxies bound together by their mutual gravitational attraction. The largest member of this cosmic dance troupe is the Andromeda Galaxy, a spiral galaxy even larger than our own, located about 2.5 million light-years away. Despite this enormous distance, gravity is slowly but inexorably pulling our two galaxies together. In approximately 4 billion years, the Milky Way and Andromeda will merge in a slow-motion collision that will fundamentally reshape both galaxies. This galactic ballet will unfold over hundreds of millions of years, with stars from both galaxies being flung into new orbits as the two spiral structures blend and ultimately form a single, larger elliptical galaxy. The local group itself is part of an even larger structure called the Virgo supercluster, which contains thousands of galaxies spread across roughly 100 million light-years. And this supercluster is just one of many such structures scattered throughout the observable universe, each one held together by the persistent, patient pull of gravity. These cosmic assemblages form a web-like pattern on the largest scales, with dense filaments of galaxies connected by vast, relatively empty voids. This cosmic web, as astronomers call it, represents the largest scale structure in the universe, a testament to gravity's ability to organize matter across distances so vast that light itself takes billions of years to cross them. What makes this cosmic choreography even more remarkable is that most of the dancers remain invisible to us. The matter we can see, the stars, planets, gas clouds, and galaxies that shine with their own light, or reflect the light of others, represents only about 5% of the total mass and energy in the universe. The remaining 95% consists of dark matter and dark energy, mysterious components that reveal themselves only through their gravitational effects. Dark matter, which makes up about 27% of the universe, acts as an invisible scaffolding that helps hold galaxies and galaxy clusters together. Without dark matter's additional gravitational pull, the stars and galaxies would fly apart, unable to maintain their spiral structures or remain bound in their cosmic neighborhoods. Dark energy, even more enigmatic than dark matter, comprises roughly 68% of the universe and appears to be causing the expansion of space itself to accelerate. This means that while gravity works to pull structures together on local scales, dark energy is simultaneously pushing the universe apart on the largest scales. The result is a cosmic tug-of-war, with gravity winning the battle to form and maintain structures like galaxies and galaxy clusters, while dark energy wins the war by ensuring that these structures become increasingly isolated from one another as the universe expands. This interplay between gravity and dark energy creates a dynamic, evolving universe where the dance of celestial bodies takes place against a backdrop of expanding space. The galaxies we observe today are not only moving through space, but are being carried along by the expansion of space itself. This means that the most distant galaxies we can see are racing away from us at speeds that approach the speed of light, not because they are moving through space at such tremendous velocities, but because the space between us and them is expanding at an accelerating rate. The cosmic dance orchestrated by gravity also operates on timescales that dwarf human experience. While we can observe the daily rotation of Earth and the annual orbit of our planet around the Sun, the larger movements of our solar system around the galaxy and the even grander motions of galaxies within their clusters unfold over millions, billions, and even trillions of years. These cosmic rhythms remind us that we are part of a universe in constant motion, where every celestial body participates in multiple nested dance patterns simultaneously. Our Sun, for instance, not only orbits the center of the Milky Way, but also bobs up and down relative to the galactic plane as it travels, creating a wave-like motion through space. Meanwhile, the entire local group of galaxies is falling toward a massive collection of galaxy clusters known as the Great Attractor, a gravitational anomaly that exerts its influence across hundreds of millions of light years. Even this Great Attractor is part of an even larger structure, the Laniakea supercluster, which encompasses our local group and tens of thousands of other galaxies in a cosmic dance that spans 500 million light years. These vast scales and enormous timescales can make the cosmic dance seem abstract and removed from our daily experience. But the beauty of gravity lies in its universality. The same physical principles that govern the motion of planets around stars also govern the motion of stars around galactic centers and the motion of galaxies around each other. The mathematics that Newton developed to describe falling apples and orbiting moons applies equally well to the grandest structures in the universe, though Einstein's refinements become increasingly important as we venture into regions where gravity becomes extremely strong or where objects move at significant fractions of the speed of light. This universality means that by studying the dance of planets in our own solar system, we gain insights into the behavior of objects throughout the cosmos. The same elliptical orbits that Kepler discovered for Mars and the other planets appear again and again in different contexts. Binary stars orbiting each other, globular clusters of stars orbiting the outskirts of galaxies, and even entire galaxies following elliptical paths around the centers of their galaxy clusters. The resonances that help maintain the stability of planetary orbits also appear in the rings of Saturn, the asteroid belt, and the distribution of galaxies in the cosmic web. As we continue to develop more sophisticated tools for observing the universe, from space-based telescopes that can peer deeper into cosmic history, to gravitational wave detectors that can sense the ripples in space-time caused by colliding black holes, we are gaining an ever more detailed understanding of how gravity shapes the cosmos. These observations reveal a universe that is far more dynamic and interconnected than previous generations could have imagined, where the dance of celestial bodies creates a symphony of motion that spans from the smallest asteroids to the largest superclusters of galaxies. The cosmic dance continues to evolve, with new discoveries regularly reshaping our understanding of how gravity operates on the largest scales. Recent observations have revealed galaxies that formed much earlier in cosmic history than previously thought possible, suggesting that gravity was able to pull together the first stellar nurseries more quickly than astronomers had expected. Other discoveries have shown us galaxies that appear to contain much less dark matter than theory predicts, challenging our understanding of how these invisible dancers contribute to the cosmic choreography. Perhaps most remarkably, we are beginning to witness the cosmic dance directly through the detection of gravitational waves, ripples in the fabric of space-time itself that carry information about some of the universe's most violent and energetic events. When two black holes spiral into each other and merge, they create gravitational waves that travel outward at the speed of light, carrying with them the signature of their final cosmic dance. These waves, first predicted by Einstein more than a century ago, provide us with an entirely new way of observing the universe, one that allows us to hear the cosmic dance rather than simply see it. As we stand on our small planet, orbiting our ordinary star, in our typical galaxy, within our modest galaxy cluster, we are participants in a cosmic dance that encompasses everything from the quantum fluctuations that seeded the first structures in the universe to the vast web of galaxies that stretches across billions of light years. Every step we take, every breath we draw, every heartbeat that marks the passage of our brief time in this cosmic ballet occurs within the embrace of gravity's gentle but inexorable pull. The dance continues, has always continued, and will continue long after our sun has exhausted its nuclear fuel and our galaxy has merged with Andromeda. New stars will be born, new planets will form, and new worlds may arise, where other observers will look up at their night sky and marvel at the beauty of the cosmic dance, just as we do today. In this eternal choreography, we are both audience and performer, observer and participant, temporary notes in a symphony that plays across the vast concert hall of space and time. As we drift deeper into our cosmic journey, we find ourselves at perhaps the most wondrous chapter yet, how these scattered lights in the darkness began to dance together. You see, galaxies aren't solitary wanderers, they're social creatures, drawn to one another by invisible threads that stretch across the universe like the most delicate cosmic web you could imagine. Picture this, it's been a few billion years since the first stars flickered to life. The universe has grown larger, cooler, more spacious. Those early proto-galaxies, those rough-hewn collections of stars we spoke of, have begun to mature. Some have settled into elegant spirals, their arms sweeping gracefully through space like frozen hurricanes. Others have puffed up into gentle ellipticals, round and serene as cosmic soap bubbles. And a few, bless them, remain delightfully chaotic, irregular, and unpredictable as abstract art painted across the void. But here's where the story takes a turn toward the magical. These galaxies, for all their individual beauty, cannot resist the gentle pull of their neighbors. Gravity, that patient sculptor we've come to know so well, has been weaving connections between them. Not visible threads, mind you, but pathways of influence that draw galaxies together into groups, clusters, and eventually into structures so vast they challenge our ability to comprehend them. Our own Milky Way lives in what astronomers have lovingly named the local group. It's a rather modest neighborhood by cosmic standards, home to perhaps 50 or so galaxies, most of them small and quiet. We share this celestial suburb with our grand neighbor Andromeda, a spiral galaxy much like our own, but slightly larger, slightly more dramatic in her presentation. Together, we're the twin anchors of this little community, with dozens of smaller galaxies orbiting around us like devoted companions. Some of these smaller galaxies you might recognize. The large and small Magellanic Clouds, visible to the naked eye from the southern hemisphere, are actually small irregular galaxies that have been caught in our gravitational embrace. They're slowly being pulled apart by our influence, their gas, and stars gradually joining the Milky Way's grand spiral. It's not violent, this cosmic choreography. It's more like a slow, graceful waltz that takes hundreds of millions of years to complete. But the local group is just the beginning. Zoom out further, and you'll discover that galaxy groups like ours are themselves part of even grander structures. Clusters of galaxies containing hundreds or even thousands of members bound together by gravity and swimming through space like vast schools of luminous fish. The nearest large cluster to us is the Virgo cluster, a magnificent collection of over 1,000 galaxies centered around a giant elliptical galaxy called Messier 87. In these dense clusters, the gravitational interactions become more complex, more dynamic. Galaxies don't just orbit peacefully, they collide, merge, and transform. When two spiral galaxies meet in such an environment, their delicate structures can be completely disrupted. The orderly rotation that created their beautiful arms is scrambled, and what emerges from the collision is often a large, featureless elliptical galaxy. It's cosmic recycling on the grandest scale, where the ashes of old structures become the building blocks of new ones. And still, we're not done scaling up. These clusters themselves are organized into superclusters, structures so enormous that light takes hundreds of millions of years to cross them. Our local group, along with the Virgo cluster and dozens of other galaxy clusters, all belong to something called the Laniakea supercluster. The name comes from Hawaiian words meaning immense heaven, and it contains about 100,000 galaxies spread across 520 million light-years of space. But perhaps the most breathtaking discovery of all is that these superclusters aren't randomly scattered through space. They're organized into an intricate pattern that astronomers call the cosmic web. Imagine the universe as a vast, three-dimensional spider web with galaxies strung along its filaments like dewdrops on silk. These filaments, made primarily of dark matter and gas, stretch across hundreds of millions of light years, connecting distant regions of the universe in an elegant, interconnected network. Between these filaments lie the voids, vast, empty regions where few galaxies dare to venture. Some of these voids are so large that you could fit thousands of Milky Ways inside them and still have room to spare. They're not completely empty, mind you, but they're so sparsely populated that a galaxy wandering through such a region would be profoundly alone, its nearest neighbor perhaps tens of millions of light years away. This cosmic web, this grand architecture of the universe, didn't emerge by chance. It grew from those tiny quantum fluctuations we mentioned earlier, the microscopic ripples in the fabric of space-time that were stretched to cosmic proportions during the universe's first moments. Over billions of years, gravity amplified these ripples, drawing matter together along the densest threads while leaving the spaces between them increasingly empty. What's remarkable is that we can trace this structure not just through space, but through time. When we look at the most distant galaxies, we're seeing them as they were when the universe was young, and we can watch the cosmic web gradually taking shape. The earliest galaxies appear to be scattered more randomly, but as cosmic time progresses, the familiar pattern of filaments and voids becomes increasingly clear. And this web is still evolving. Dark energy, that mysterious force driving the universe's accelerating expansion, is slowly stretching the connections between galaxy clusters. Over the next hundreds of billions of years, the cosmic web will become increasingly sparse, with galaxy clusters drifting farther and farther apart until they become isolated islands in an ever-expanding sea of space. But for now, in this cosmic moment we call the present, the universe is beautifully, intricately connected. Every galaxy, including our own, is part of this vast web of relationships. The Milky Way's motion through space is influenced by the gravitational pull of Andromeda, which is itself being tugged by the Virgo cluster, which flows along the filaments of the cosmic web towards some distant gravitational attractor we're only beginning to understand. It's a humbling thought, isn't it? That our entire galaxy, with its hundreds of billions of stars, and all the worlds that might orbit them, is but a single note in this cosmic symphony. And yet, that note matters. Every galaxy, no matter how small or distant, contributes to the overall structure and evolution of the universe. We are all connected, all part of this grand dance that began with the first stirrings of matter in the primordial darkness and continues to this day. So as you settle deeper into sleep tonight, let your mind drift along these cosmic highways. Picture the gentle streams of galaxies flowing along invisible filaments, the great clusters spinning slowly through space, the vast voids echoing with ancient light. We are part of something magnificent, something almost impossibly vast and beautiful. The cosmic web cradles us all, connecting every star, every world, every dreaming mind to the grand story of the universe itself. Welcome back to The Sleepy Scientist, where wonder meets weariness and the cosmos gently cradles you toward rest. Tonight we're drifting through one of the most elegant chapters in the universe's story, the intricate dance of planets, moons, and stars bound together by gravity's invisible choreography. We've journeyed far together through the birth of galaxies, the formation of stellar nurseries, and the grand architecture of space-time itself. Now we turn our attention to something more intimate, yet equally profound: how celestial bodies move through space in patterns so precise they've guided sailors, inspired poets, and revealed the very laws that govern reality. Before we begin this gentle voyage through orbital mechanics and gravitational poetry, I'd love to know where you're listening from tonight and what time it is in your corner of the world. There's something beautifully fitting about discussing planetary motion while we're all scattered across different time zones, each of us riding our own spinning world through the darkness. If you find comfort in these quiet cosmic journeys, I'd be grateful if you'd give this video a gentle like or consider subscribing. It helps other restless minds find their way to this peaceful corner of the universe. And if this exploration proves too fascinating for sleep, well, at least you'll drift off knowing a bit more about the celestial mechanics that keep our world turning. So settle in, let your breathing slow, and prepare to witness the universe's most graceful performance, the eternal ballet of worlds in motion, where gravity serves as both composer and conductor, orchestrating a symphony that has played without pause for billions of years. In the beginning, there was chaos. Not the kind of dramatic chaos you might imagine from Hollywood depictions of cosmic catastrophe, but something far more subtle and profound. Picture the early solar system 4.5 billion years ago, a swirling disk of gas and dust surrounding a young temperamental star we now call the Sun. This primordial disk, known as the solar nebula, was a realm of constant motion, where particles collided, stuck together, and gradually built the foundation of everything we know. The dance began with accretion, a process so gentle it's almost poetic. Tiny grains of dust, no larger than smoke particles, would encounter each other in the cosmic dark and cling together through electrostatic forces. These growing clumps attracted more material through their own modest gravitational pull, slowly building into larger and larger bodies. It was a patient process, requiring millions of years to transform microscopic dust into mountain-sized planetesimals. But even as these early building blocks formed, they were already beginning to dance. The conservation of angular momentum, the same principle that causes a figure skater to spin faster when they pull their arms inward, meant that as the solar disk contracted, it spun faster. This rotation naturally flattened the disk into a thin plane, establishing the stage upon which all future orbital choreography would unfold. Within this spinning disk, gravity began to play favorites. The most massive concentrations of material attracted more and more matter, growing into what we now recognize as the planets. But their growth wasn't uniform or peaceful. The early solar system was a violent place, filled with catastrophic collisions that would reshape worlds and scatter debris across vast distances. The moon itself is thought to be the result of one such collision when a Mars-sized object struck the young Earth and flung molten rock into orbit. Yet even in this apparent chaos, the fundamental laws of physics were quietly establishing order. Each collision, each gravitational interaction, was governed by the same principles that would eventually create the stable, predictable orbits we observe today. The planets weren't just forming, they were learning to dance, finding their rhythm in the cosmic ballet that gravity had choreographed. As the solar system matured, the dance became more refined. Jupiter, the massive giant, emerged as the system's primary gravitational conductor, its immense mass influencing the orbits of every other body in the solar system. Its gravitational pull helped clear the asteroid belt, prevented the formation of a planet between Mars and Jupiter, and even influenced the delivery of water to the inner planets. In many ways, Jupiter served as both protector and destroyer, shaping the solar system's architecture through its gravitational dominance. The smaller planets, meanwhile, settled into their own unique rhythms. Mercury, closest to the Sun, races through its orbit in just 88 Earth days, while distant Neptune takes 165 Earth years to complete a single lap. Each world found its own tempo in the cosmic symphony, their orbital periods determined by their distance from the Sun and the immutable laws of celestial mechanics. But the true beauty of this gravitational ballet lies not in the individual performances of planets, but in their collective harmony. The solar system is a masterpiece of dynamic stability, where each world's motion influences and is influenced by every other body. It's a delicate balance that has persisted for billions of years, a testament to the elegant precision of gravitational choreography. Even today, as you rest and prepare for sleep, this ancient dance continues. The Earth beneath you spins on its axis while simultaneously orbiting the Sun, carrying you through space at speeds that would make the fastest aircraft seem stationary. The moon tugs at our oceans, creating the tides that have shaped life on Earth for eons. And throughout the solar system, moons orbit planets, asteroids trace their elliptical paths, and comets sweep in from the outer darkness, all following the same gravitational rules that have governed their motion since the beginning. This is the foundation of our cosmic ballet, a dance that began in chaos but found its rhythm through the patient, persistent pull of gravity. As we explore the intricate steps of this celestial choreography in the chapters ahead, remember that you are not merely an observer of this dance. You are a participant, riding aboard spaceship Earth as it pirouettes through the cosmos, part of the same gravitational symphony that has been playing since the solar system's birth. So far, we've journeyed through the cosmos together, watching gravity weave its silent masterpiece across billions of years. We've seen how this invisible force shaped the early universe, pulling together the first wisps of hydrogen and helium into the building blocks of everything we know. We've marveled at how gravity orchestrated the cosmic web, that vast scaffolding of dark matter and ordinary matter that forms the backbone of our universe. And we've witnessed the delicate dance of planets, moons, and stars as they follow gravity's patient choreography, through space and time. Now, as we continue our gentle drift through the cosmos, we turn our attention to something truly extraordinary: the intricate patterns that emerge when celestial bodies dance together in perfect mathematical harmony. These are called orbital resonances, and they represent some of the most beautiful examples of gravity's subtle artistry. Picture, if you will, a cosmic ballet where planets, moons, and asteroids don't just orbit randomly around their gravitational partners, but instead lock into elegant rhythms with one another. It's as if the universe has its own internal metronome, keeping time across millions of miles of empty space. These resonances occur when the orbital periods of two or more celestial bodies form simple mathematical ratios, creating patterns that repeat with clockwork precision across cosmic time. Perhaps the most famous example lies in our own solar system, in the fascinating relationship between Jupiter's moons Io, Europa, and Ganymede. These three worlds have settled into what astronomers call a 4:2:1 resonance. For every 4 orbits that Io completes around Jupiter, Europa completes exactly 2, and Ganymede completes exactly 1. It's a perfect celestial waltz, choreographed by gravity over millions of years. This isn't mere coincidence. When moons or planets first form, their orbits are often chaotic and unstable, but gravity, that patient sculptor, slowly nudges them into these stable configurations. It's a process that can take millions of years, like a cosmic tuning fork, gradually bringing disparate notes into harmony. The resonance provides stability, ensuring that these bodies don't crash into each other or get flung out into the cold darkness of space. But resonances aren't limited to Jupiter's moons. They appear throughout our solar system like hidden musical notes in a grand symphony. Neptune and Pluto, for instance, are locked in a 3:2 resonance. For every 3 orbits Neptune makes around the Sun, Pluto completes exactly 2. This relationship has kept these two worlds in their cosmic dance for billions of years, never allowing them to come dangerously close to one another, despite their orbits appearing to cross when viewed from certain angles. Even more remarkable are the resonances we find in Saturn's ring system. Those magnificent rings, which have captivated human imagination since Galileo first glimpsed them through his telescope, are sculpted and maintained by a complex web of gravitational resonances with Saturn's many moons. The gaps in the rings, like the famous Cassini division, exist because particles in those regions would be in resonance with moons like Mimas. The repeated gravitational tugs from these moons gradually clear out the ring particles, creating the beautiful structure we observe today. It's worth pausing to consider the sheer improbability of these arrangements. The odds of such precise mathematical relationships occurring by chance are astronomically small. Yet here they are, scattered throughout our solar system and beyond, testament to gravity's ability to create order from chaos, beauty from randomness. These resonances represent a kind of cosmic memory, preserving the story of how our solar system evolved and settled into its current configuration. The study of orbital resonances has also revolutionized our understanding of planetary formation. Computer simulations show us that in the early solar system, planets didn't simply form where we find them today. Instead, they migrated inward and outward, pushed and pulled by gravitational interactions with the disk of gas and dust from which they formed. During this migration, planets could capture each other into resonances, creating chains of worlds locked in mathematical harmony. This process helps explain some of the puzzling features of our solar system. Why, for instance, do we find so many asteroids grouped together in the asteroid belt, while other regions remain relatively empty? The answer lies in resonances with Jupiter. The massive planet's gravitational influence creates a complex pattern of stable and unstable zones throughout the asteroid belt. Asteroids in resonance with Jupiter can remain stable for billions of years, while those in non-resonant orbits are gradually perturbed and removed. Perhaps even more fascinating are the resonances we've discovered around other stars. The Kepler Space Telescope and other planet-hunting missions have revealed that resonant chains of planets are surprisingly common throughout the galaxy. Some of these systems are even more tightly packed and precisely tuned than anything we see in our own solar system. The TRAPPIST-1 system, for example, contains 7 Earth-sized planets locked in a complex chain of resonances, creating a gravitational symphony that has been playing for billions of years. These discoveries have profound implications for our understanding of how planetary systems form and evolve. They suggest that the migration and resonant capture of planets is not just a curiosity of our own solar system, but rather a fundamental process in planetary system formation throughout the universe. Every resonant system we discover is like finding another instrument in the cosmic orchestra, each one adding its own unique harmony to the grand composition of the universe. The mathematics underlying these resonances is both elegant and profound. At its heart, it's about the accumulation of small effects over vast periods of time. Each time 2 orbiting bodies reach the same relative configuration, they experience a tiny gravitational tug. Individually, these tugs are insignificant, but when they occur repeatedly, always at the same point in the orbit, they can accumulate into powerful forces that reshape entire planetary systems. This is gravity working not through brute force, but through patience and precision. It's the difference between a sledgehammer and a tuning fork. Where other forces might shatter or scatter, gravity gently guides celestial bodies into configurations of exquisite mathematical beauty. The resonances we observe today are the result of countless small adjustments, each one moving the system incrementally toward greater stability and harmony. And the dance continues even now. The resonances we observe are not static, frozen arrangements, but living, breathing relationships that continue to evolve over cosmic time. Tidal forces slowly change orbital periods. New bodies can be captured into the resonant chain, and external perturbations can sometimes break the delicate balance, sending the system into a new configuration. In a sense, every resonant system is both ancient and eternally young. Ancient because it preserves the memory of how it formed billions of years ago, and young because it continues to evolve and adapt with each passing orbit. These systems remind us that the universe is not a collection of separate, isolated objects, but rather a vast web of relationships, each body influencing and being influenced by every other body through the patient, persistent pull of gravity. As you drift towards sleep tonight, perhaps you can imagine yourself floating among these resonant worlds, feeling the gentle rhythmic tugs that keep them in their eternal dance. In the quiet darkness, you might hear the mathematical music that plays throughout the cosmos, a symphony written in the language of orbital mechanics and performed by planets, moons, and asteroids across the vast concert hall of space. It's a lullaby that has been playing since the solar system was young, and it will continue long after we're gone. Gravity's gift to the universe, a reminder that even in the cold emptiness of space, there is beauty, there is order, and there is an invisible hand guiding the cosmic dance. As we drift deeper into the cosmic ballet, we encounter one of the most breathtaking displays of gravitational choreography in our universe, the orbital resonances of planetary systems. These aren't random cosmic coincidences, but rather elegant mathematical relationships that emerge when gravity finds its perfect rhythm, creating stability from what could otherwise be chaos. Think of orbital resonance as a cosmic waltz, where planets move in synchronized patterns that repeat over and over again. When 2 or more celestial bodies orbit with periods that form simple numerical ratios, they create what astronomers call resonance. It's gravity's way of finding harmony, like musical notes that sound beautiful together because their frequencies align in pleasing proportions. Jupiter's 4 largest moons, discovered by Galileo himself over 4 centuries ago, offer us perhaps the most famous example of this celestial choreography. Io, Europa, and Ganymede dance together in what's called a 4-to-2-to-1 resonance. For every 4 orbits that Io completes around Jupiter, Europa completes exactly 2, and Ganymede completes precisely 1. This isn't mere coincidence, it's gravity conducting a symphony of motion that has played for billions of years. This resonant dance creates a fascinating interplay of gravitational tugs and pulls. As these moons align periodically, they experience stronger gravitational forces that actually help maintain their orbital stability. It's as if they're holding hands across the void, each one helping to keep the others in their proper cosmic lanes. The energy that builds up during these alignments gets redistributed through the system, preventing any single moon from wandering too far from its designated path. But the magic of orbital resonance extends far beyond Jupiter's family. In our own solar system, Neptune and Pluto share a remarkable 3-to-2 resonance, with Neptune completing 3 orbits for every 2 that Pluto manages. This relationship actually protects Pluto from ever getting too close to Neptune, despite their orbits crossing on paper. When you map their positions over time, you discover that they're engaged in an eternal dance that keeps them safely apart, never approaching closer than about 17 astronomical units. The asteroid belt between Mars and Jupiter tells another story of resonance, though this one speaks of absence rather than presence. There are gaps in the asteroid belt, called Kirkwood gaps, where very few asteroids are found. These empty spaces correspond exactly to orbital periods that would create resonances with Jupiter. Any asteroid unlucky enough to find itself in one of these resonant relationships gets its orbit gradually perturbed by Jupiter's massive gravitational influence, eventually being ejected from the belt entirely. It's as if Jupiter is a cosmic gardener, carefully weeding out asteroids that dare to dance too closely to its rhythm. The discovery of exoplanets has revealed that orbital resonance is not just a local phenomenon, but a fundamental organizing principle throughout the galaxy. The TRAPPIST-1 system, located about 40 light-years from Earth, hosts 7 Earth-sized planets locked in a spectacular chain of resonances. Moving outward from their star, the planets maintain period ratios of approximately 8-to-5, 5-to-3, 3-to-1-2, 3-to-2, 4-to-3, and 3-to-2. It's like a cosmic music box, with each planet keeping perfect time with its neighbors in an intricate, never-ending performance. What makes these resonant systems so remarkable is their stability. Computer simulations show that planets in resonance can maintain their orbital relationships for billions of years, far longer than planetary systems where the orbits are more randomly arranged. The resonances act like gravitational safety nets, preventing the system from descending into chaos, even when subjected to external perturbations. This stability emerges from a beautiful principle. Resonant systems naturally settle into configurations that minimize the total energy of the system while maintaining the angular momentum. It's as if gravity is an artist, constantly adjusting and fine-tuning until it achieves the most elegant possible arrangement. The planets don't just orbit their star, they orbit in harmony with each other, creating patterns that repeat with clockwork precision across cosmic time. The formation of these resonant systems tells us something profound about how planetary systems evolve. Young planets don't simply form in resonance by accident. Instead, they migrate through their primordial disks of gas and dust, their orbits gradually shifting until they become trapped in these stable, resonant configurations. It's a process that requires exquisite timing and just the right conditions, like cosmic clockwork assembling itself from the raw materials of stellar birth. Some resonances are more stable than others. The 2-to-1 resonance, where one planet completes exactly 2 orbits for every 1 orbit of its neighbor, is particularly common and long-lasting. These planets experience regular gravitational nudges that help maintain their orbital eccentricities and prevent their orbits from becoming perfectly circular. This slight elongation in their paths creates a rhythmic variation in the gravitational forces they experience, like a gentle cosmic breathing that keeps the system alive and dynamic. Perhaps most wonderfully, these resonant relationships create predictable patterns that cascade through entire planetary systems. When three or more planets are locked in resonance, they form what astronomers call a resonant chain. Each planet's motion influences its neighbors, creating waves of gravitational influence that ripple through the system like stones thrown into a perfectly still pond. The result is a kind of planetary music, with each world contributing its own note to a harmony that spans millions of kilometers. Even more fascinating is how these resonances can protect smaller bodies within planetary systems. Trojan asteroids, for example, share Jupiter's orbit but remain trapped in stable points 60 degrees ahead of or behind the giant planet. They're locked in a one-to-one resonance with Jupiter, completing one orbit for every one of Jupiter's orbits, but positioned in such a way that they never approach the planet directly. It's like having a cosmic escort, with Jupiter's gravity simultaneously holding them in place and keeping them at a respectful distance. The mathematics of orbital resonance reveals something beautiful about the underlying structure of our universe. These aren't just mechanical relationships, but expressions of deeper principles about how complex systems organize themselves. The same mathematical relationships that govern planetary orbits can be found in the rings of Saturn, the oscillations of pendulums, and even the quantum energy levels of atoms. Resonance, it seems, is one of nature's favorite ways of creating order from chaos. As we continue to discover new exoplanetary systems, we're finding that resonant configurations are surprisingly common. This suggests that the formation of stable, long-lived planetary systems naturally tends toward these harmonious arrangements. It's as if the universe has an inherent preference for elegance, constantly working to transform the random violence of planetary formation into the serene clockwork of orbital resonance. Tonight, as you drift towards sleep, remember that you're part of a cosmos where gravity conducts an endless symphony of motion. Worlds dance in mathematical harmony across the darkness, their orbits locked in relationships so precise they would make a clockmaker weep with envy. In this grand gravitational ballet, every planet knows its place, every moon keeps perfect time, and the music of the spheres plays on, eternal and beautiful, in the vast concert hall of space. The cosmic dance continues, not just in the vastness of space between galaxies, but in the very structure of space-time itself. We've witnessed how gravity sculpts the universe on the grandest scales, weaving galaxies into clusters and superclusters, but there's an even more fundamental choreography at play, one that operates on scales so vast it encompasses everything we can observe and reaches into dimensions we're only beginning to understand. Dark matter, that invisible partner we've met before, doesn't just influence individual galaxies. It forms the scaffolding of the entire universe, creating what cosmologists call the cosmic web. Picture the universe as a vast three-dimensional spider web with dark matter filaments stretching across hundreds of millions of light years. Where these filaments intersect, matter pools and galaxies cluster together like cosmic cities. Between the filaments lie the voids, enormous empty regions where few galaxies dare to venture, stretching across spaces so vast that light from one side takes hundreds of millions of years to reach the other. This isn't just structure, it's architecture on a scale that dwarfs our imagination. The local group, our galactic neighborhood containing the Milky Way and Andromeda, is just one tiny node in this cosmic web. We're part of the Virgo supercluster, which itself is just a small section of an even larger structure called the Laniakea supercluster, stretching across 520 million light-years and containing the mass of 100 quadrillion suns. And Laniakea is just one of countless similar structures scattered throughout the observable universe. But here's where the story takes a remarkable turn. This cosmic web isn't static, Frozen in time like some celestial sculpture, it's dynamic, constantly evolving, driven by forces that operate on timescales so vast they make the formation of our solar system seem like a brief moment. Gravity pulls matter along the filaments, feeding the growth of galaxy clusters. Smaller structures merge into larger ones in a hierarchical dance that's been playing out for over 13 billion years. Yet even as gravity works to pull things together, another force works against it. Dark energy, even more mysterious than dark matter, pervades all of space and drives the accelerating expansion of the universe. It's not just that galaxies are moving away from each other, they're moving away faster and faster as time goes on. This cosmic tug of war between gravity trying to pull things together and dark energy pushing them apart shapes the ultimate fate of every structure in the universe. The dance between these forces creates a delicate balance. In regions where dark matter is particularly dense, gravity wins and magnificent structures form. Galaxy clusters grow larger, more massive, pulling in surrounding matter like cosmic vacuum cleaners. But in the spaces between, dark energy dominates, stretching the fabric of space itself and ensuring that the voids grow ever larger and emptier. This interplay extends to the smallest details of galactic behavior. When galaxies fall into massive clusters, they don't just join a quiet neighborhood. They enter a bustling, chaotic environment where gravitational forces strip away their outer stars, ram pressure from hot intergalactic gas tears away their star-forming material, and close encounters with other galaxies reshape their very structure. Many of the elliptical galaxies we observe today are the products of these cluster encounters, their spiral arms long since disrupted, their star formation quenched by the harsh cluster environment. The cosmic web also channels the flow of pristine gas from the voids into the filaments and eventually into galaxies themselves. This isn't just empty space between structures, it's a network of supply lines, feeding the continued growth and evolution of galaxies. When we observe a galaxy forming new stars, we're witnessing the end result of a process that began with gas flowing along dark matter filaments across hundreds of millions of light years. Perhaps most remarkably, this vast cosmic architecture influences the very chemistry of the universe. As gas flows along the filaments, it carries with it the heavy elements forged in the hearts of dying stars. Iron created in a supernova in one galaxy can travel vast distances before being incorporated into a new star in a completely different galaxy. The cosmic web becomes a circulation system, distributing the building blocks of planets and life throughout the universe. Even the orientation of galaxies reflects this grand structure. Galaxies don't point randomly in space. They tend to align with the filaments of the cosmic web, like compass needles following invisible magnetic field lines. Their rotation axes, the directions of their spiral arms, even the orbits of their satellite galaxies all carry the fingerprints of the larger structure they're embedded within. This cosmic choreography operates on scales that challenge our ability to comprehend them. The light we see from distant galaxy clusters began its journey when the universe was less than half its current age. We're observing the cosmic web not as it is, but as it was billions of years ago, watching the slow-motion dance of structure formation play out across cosmic time. And the dance continues today. Right now, as you listen to these words, galaxy clusters are colliding in slow-motion ballets that will reshape their structure over the next billion years. Dark matter halos are merging in gravitational embraces that will determine the fate of the galaxies they contain. New filaments of the cosmic web are forming, while others are being stretched thin by the expansion of space. We are not separate from this dance. Every atom in your body was once part of this cosmic web, flowing along its filaments, processed through multiple generations of stars, and eventually finding its way to the small rocky planet we call home. You are made of cosmic web material, shaped by forces that operate across the entire observable universe, a temporary arrangement of matter that has learned to contemplate its own origins. The gravity ballet extends beyond what we can see, beyond what we can measure, into the deepest structures of reality itself. And in this vast, unending dance of dark matter and dark energy, of clustering and expansion, of creation and dissolution, we find ourselves perfectly positioned to observe, to wonder, and to slowly unravel the magnificent choreography that surrounds us on every scale imaginable. Here's part 10 of The Sleepy Scientist, The Gravity Ballet, How Planets Dance in Space. But gravity's artistry extends far beyond individual planetary systems and galaxies. On the grandest scales imaginable, it has woven the entire universe into a vast, interconnected web of structure and motion. This cosmic web, as astronomers call it, is perhaps gravity's most ambitious masterpiece, a three-dimensional tapestry that spans billions of light years and connects every galaxy, every star, every planet in an invisible network of gravitational influence. Picture, if you will, the universe as a vast sponge with dense filaments of dark matter stretching between enormous voids. Along these filaments, like pearls on cosmic strings, galaxies cluster and flow in great rivers of light. The Milky Way itself sits within one such filament, part of what we call the local supercluster, drifting along invisible currents that were set in motion shortly after the Big Bang itself. These cosmic currents are not random. They follow the gentle guidance of gravity, channeled by the distribution of dark matter that we cannot see but whose presence we feel in every galactic dance. Dark matter, that mysterious substance that outweighs ordinary matter 5 to 1, forms the scaffolding upon which all visible structure hangs. Without it, galaxies would fly apart, stars would scatter like leaves in the wind, and the elegant spiral arms we admire would unravel into chaos. Yet even as gravity builds these grand structures, another force works against it. Dark energy, even more mysterious than dark matter, drives the expansion of space itself, pushing distant galaxies ever farther apart. It's a cosmic tug-of-war between gravity's desire to pull everything together and dark energy's relentless push toward separation. On small scales, gravity wins, binding planets to stars and stars to galaxies. But on the largest scales, dark energy dominates, ensuring that the universe continues to expand and cool, carrying distant galaxies beyond our cosmic horizon. This interplay between gravity and dark energy creates a universe in delicate balance, neither collapsing under its own weight nor expanding so rapidly that structure cannot form. It's a balance that has allowed billions of years for the slow work of planet formation, for the patient accumulation of elements in stellar cores, for the gradual development of conditions suitable for complexity, and eventually for life itself. Consider the remarkable chain of gravitational relationships that brought you to this moment. The Big Bang created the initial fluctuations in density that gravity could work with. Those fluctuations grew into the cosmic web, channeling matter into the filaments where galaxies could form. Within those galaxies, gravity gathered gas into stars, forged heavy elements in stellar cores, and scattered them through supernovae into the interstellar medium. From that enriched material, new generations of stars formed, accompanied by planetary systems where rocky worlds could accumulate the complex chemistry of carbon and water and life. Our solar system formed within this grand context, inheriting not just the heavy elements created by countless generations of stars, but also its place in the galactic disk, its orbit around the galactic center, its motion through the local group of galaxies. We are not isolated wanderers, but participants in a cosmic dance that began nearly 14 billion years ago and continues still. The gravitational influences that shape our cosmic neighborhood extend far beyond what we might expect. The Milky Way's encounter with the Andromeda Galaxy, still billions of years in the future, is already subtly influencing the orbits of stars in both galaxies. The gravitational pull of the Great Attractor, a massive concentration of galaxies hundreds of millions of light years away, tugs gently on our local group, adding its influence to our cosmic trajectory. Even the largest structures in the universe, the superclusters and vast filaments of the cosmic web, contribute their whispered gravitational signals to the symphony of forces that guide our motion through space. This interconnectedness reveals one of gravity's most profound qualities, its infinite reach. Every particle of matter in the universe exerts a gravitational influence on every other particle, no matter how distant. The effect may be vanishingly small, but it is never zero. You are gravitationally connected to every star in the Milky Way, every galaxy in the local group, every distant quasar at the edge of the observable universe. It's a connection so tenuous as to be unmeasurable, yet it speaks to a fundamental unity underlying all of existence. Modern astronomy has revealed that this cosmic web is not static but dynamic, constantly evolving as gravity continues its patient work. Galaxies flow along filaments toward massive clusters, where they may merge or be torn apart by tidal forces. New stars form in the compressed gas of galaxy collisions, while others are flung into the lonely spaces between galaxies. The cosmic web itself evolves, with filaments growing thicker and voids expanding as the universe ages, and dark energy drives ever greater separation between distant structures. We are living witnesses to this ongoing evolution, inhabitants of a universe still in the process of becoming. The cosmic web that surrounds us is not a finished cathedral, but a construction site, with gravity as the master builder, working on timescales so vast that billions of human lifetimes pass like moments in its patient construction. Yet even as we observe this grand architecture, we are reminded that we are not separate from it, but woven into its very fabric, our atoms forged in stellar cores, our planet shaped by gravitational collapse, our galaxy following ancient currents in the cosmic web. In the end, gravity's ballet encompasses everything from the smallest pebble falling to Earth to the grandest flows of galaxies across cosmic time. It is a dance of such scope and beauty that it challenges our ability to comprehend it fully, yet it is also intimate enough that we feel its effects in every breath, every heartbeat, every step we take. We are dancers in gravity's ballet, partners in a cosmic choreography that began with the universe itself and will continue long after our sun has faded to a cooling ember among the stars. As you drift towards sleep tonight, perhaps you can sense something of this grand dance, this gentle pulling and pushing that connects you to everything that was, is, and ever will be. You are not just on a planet orbiting a star, but part of a vast cosmic web of gravitational relationships that spans the observable universe, a participant in gravity's eternal ballet, dancing your small but essential part in the greatest performance ever staged. We've journeyed far together through the cosmic dance of gravity, from the universe's earliest moments when quantum whispers became the seeds of structure, to the vast cosmic web that stretches across space like nature's most magnificent tapestry. We've watched dark matter weave its invisible threads, binding galaxies in their stately orbits, and witnessed how gravity shapes everything from the smallest asteroid to the largest galactic cluster. But now, as we drift toward the gentle conclusion of our celestial voyage, let's consider perhaps the most beautiful aspect of gravity's grand choreography, how it connects us all in one vast, interconnected dance. Every breath you take, every step you make, happens within gravity's embrace. The blood flowing through your veins follows paths carved by gravity's patient guidance. The air around you settles and swirls according to gravitational gradients so subtle they're barely measurable, yet so essential they shape weather patterns across continents. And it's not just here on Earth. Right now, as you listen to these words, You're participating in multiple gravitational dances simultaneously. You're spinning with our planet as it rotates once every 24 hours, creating the gentle centrifugal force that makes you ever so slightly lighter at the equator than at the poles. You're orbiting the sun at roughly 30 kilometers per second, held in that perfect balance between falling toward our star and flying off into the cold darkness of space. But the dance doesn't end there. Our entire solar system is gliding through the Milky Way's spiral arms, taking about 225 million years to complete one galactic orbit. During our last trip around the galaxy's center, the first dinosaurs were just beginning to emerge on Earth. By the time we complete our next orbit, if humanity still exists, we will have witnessed changes we can barely imagine. And even our galaxy participates in larger choreographies, slowly approaching Andromeda in a cosmic waltz that will culminate in about 4 billion years. These two great spiral cities of stars will merge, their billions of inhabitants likely unharmed by the collision, but forever changed by the new gravitational landscape that emerges from their union. What's remarkable is that this dance has been unfolding for nearly 14 billion years, ever since the first tiny fluctuations in the early universe began to grow under gravity's patient influence. Those ancient ripples, stretched across space by cosmic inflation, became the seeds from which all structure grew. The cosmic microwave background still carries the faint echo of those primordial variations, a baby picture of the universe when it was only 380,000 years old. From those humble beginnings, gravity sculpted the cosmic web we see today. Dark matter formed the invisible scaffolding, creating vast filaments and nodes where ordinary matter could gather. Along these highways of the cosmos, the first stars ignited, galaxies formed, and the universe began its long transformation from a smooth, dark expanse into the rich tapestry of light and structure we observe today. The elegance of it all is breathtaking. Gravity requires no intelligence, no planning, no conscious intent. It simply follows one beautifully simple rule: masses attract. Yet from this single principle emerges all the complexity we see around us. Planets find their orbits, moons their paths, asteroids their belts. Tidal forces create the ocean's rhythm, shape the surfaces of distant worlds, and even stretch space and time itself near the most massive objects in the universe. Einstein showed us that gravity isn't really a force at all, but the curvature of space-time itself. Mass and energy tell space how to curve, and curved space tells matter how to move. It's poetry, written in the language of mathematics, a cosmic conversation between matter and the very fabric of reality. When you drop a stone, it's not being pulled downward by some mysterious force. It's simply following the straightest possible path through curved space-time, like a marble rolling along a gently sloped surface. This understanding has revealed some of the universe's most exotic phenomena. Black holes, those regions where space-time curves so extremely that not even light can escape, are gravity's most dramatic expression. They anchor galaxies, regulate star formation, and create some of the most energetic events in the cosmos. When black holes merge, they send ripples through space-time itself, gravitational waves that we can now detect with instruments so sensitive they can measure distortions smaller than 1,000th the width of a proton. And yet, for all its cosmic grandeur, gravity remains intimately personal. It shapes your posture, guides your movements, and creates the gentle pressure you feel when you lie down to rest. The weight of the blankets covering you, the settling of your body into the mattress, the way your hair falls across the pillow. All of these are gravity's tender ministrations, reminders that you are held, always held, by this most fundamental of nature's forces. As we look toward the future, gravity will continue its patient work. Stars will continue to form in the gravitational wells created by dark matter. Planets will continue their orbital dances, some perhaps harboring life that will one day gaze up at the stars and wonder, as we do, about the forces that govern the cosmos. Galaxies will continue their slow approach toward one another, creating new structures and new possibilities. The cosmic web will continue to evolve, though more slowly now, as dark energy drives the universe's expansion to accelerate. In the far future, if current models are correct, galaxies not bound to us by gravity will disappear beyond our cosmic horizon, their light stretched to undetectable wavelengths by the universe's relentless expansion. But that future is so distant, trillions of years away, that it feels more like mythology than science. For now, we exist in what might be called the universe's golden age, when stars still burn brightly, when galaxies still dance together, when gravity still builds as much as it destroys. We are witnesses to the cosmic ballet at its most magnificent, creatures of space-time, capable of contemplating the very forces that brought us into being. So tonight, as you prepare for sleep, remember that you are not separate from the cosmic dance. You are part of it. Every atom in your body was forged in the heart of a star, scattered by stellar winds or supernova explosions, and gathered again by gravity's patient hands into the remarkable arrangement that is you. You are a temporary constellation of star stuff, held together by electromagnetic forces and guided by gravity through this brief moment of consciousness. The universe is vast beyond comprehension, ancient beyond imagination, and filled with wonders that challenge our deepest understanding. Yet it is also intimate, immediate, and present in every moment of your existence. In the gentle pull you feel toward the earth, in the rhythm of tides and seasons, in the stately procession of planets across the night sky, gravity writes its endless poem of connection and belonging. Sleep well, knowing that you rest in the embrace of forces that have shaped the cosmos since time began. Dream of spirals and orbits, of dark matter, highways, and stellar nurseries, of the great dance that connects every grain of sand to every distant galaxy. Tomorrow, you will wake to a universe still turning, still dancing, still writing its story in the language of gravity and light. And perhaps in your dreams, you too will dance among the stars, weightless and free, yet forever held by the same gentle force that guides planets in their courses and whispers to every falling leaf that it belongs to something larger, something beautiful, something eternal. The gravity ballet continues, and you are both its audience and its participant, now and always, in this grand cosmic choreography that began with a whisper and will end with a sigh, having danced its way through eternity. Looking at the cosmic tapestry we've woven together, the grand story of gravity's eternal dance, we arrive at our final movement. For billions of years, this invisible choreographer has shaped everything from the tiniest quantum fluctuations to the vast cosmic web that stretches across the observable universe. We've journeyed through the birth of stars, the formation of galaxies, and the intricate orbital resonances that keep planets spinning in their celestial waltzes. We've seen how Newton's apple led to Einstein's curved space-time, how dark matter provides the scaffolding for cosmic architecture, and how supermassive black holes conduct the symphony of galactic evolution. But perhaps the most beautiful aspect of gravity's influence is its timeless persistence. Right now, as you listen to these words, the same force that ignited the first stars is gently holding you to the Earth, keeping the moon in its orbit and guiding the Milky Way through its slow dance with Andromeda. The cosmic web continues to evolve. Galaxies merge and separate, and new stars are born from the gravitational collapse of ancient nebulae. This grand ballet has no final curtain call, no moment when the music stops. It is an eternal performance, playing out across scales so vast and time frames so long that human civilizations rise and fall like individual notes in an infinite composition. The story of gravity is ultimately the story of connection. Every particle in the universe whispers to every other particle through gravitational waves rippling through space-time. Your body, composed of elements forged in the hearts of dying stars, participates in this cosmic conversation. The calcium in your bones remembers the supernova that created it. The iron in your blood once danced in the core of a star that lived and died before our solar system existed. You are not separate from the cosmic ballet, you are part of it, woven into its very fabric. As we've discovered, gravity doesn't just pull objects together, it creates the conditions for complexity to emerge. Without gravity's patient work over billions of years, there would be no stars to forge the heavy elements, no planets to provide stable environments, no galaxies to organize matter into the structures we see today. Gravity is the universe's great architect, building from the ground up, starting with quantum fluctuations and ending with the magnificent cosmic web that stretches across hundreds of millions of light years. The dance continues even now. Dark energy may be accelerating the expansion of the universe, but gravity still works tirelessly to hold local structures together. Our local galaxy group will continue its gravitational minuet for billions of years to come. New stars will form, new planets will condense from cosmic dust, and perhaps new forms of life will emerge to contemplate their place in this vast choreography. The asteroid belt between Mars and Jupiter will continue its ancient dance, prevented from forming a planet by Jupiter's gravitational influence. The rings of Saturn will shimmer and evolve, their countless ice particles each following their own precise orbital path. Looking toward the future, we can imagine how gravity will continue to shape the cosmos. In a few billion years, when the Milky Way and Andromeda galaxies finally merge, their supermassive black holes will spiral inward, creating gravitational waves that will ripple across the universe like applause for a performance well done. New stellar nurseries will form from the collision, and fresh generations of stars will light up the combined galaxy. The cosmic web will continue to evolve, with dark matter filaments guiding the flow of ordinary matter across vast distances. Even in the far future, when the last stars have burned out and the universe grows cold and dark, gravity will still be at work. Black holes will slowly evaporate through Hawking radiation, but the process will take longer than the current age of the universe multiplied by trillions upon trillions. Gravity's influence will persist until the very end, holding together the final remnants of matter as the universe expands into its ultimate fate. But we need not concern ourselves with such distant futures. Tonight, gravity cradles you gently as you rest. The same force that shapes galaxies and guides planets also keeps your blanket settled around you and ensures that your dreams, whatever cosmic adventures they may contain, unfold in the safety of Earth's gravitational embrace. The moon continues its ancient orbit overhead, pulling gently on the tides and marking the passage of time as it has for billions of years. As you drift towards sleep, remember that you are part of something magnificent and eternal. The gravity that holds you is the same force that lit the first stars, carved out the structure of the universe, and will continue orchestrating the cosmic dance long after our sun has set for the final time. You are connected to every star, every galaxy, every particle of dark matter through this invisible web of gravitational influence. In the grand ballet of the cosmos, you are both audience and performer, observer and participant. The dance goes on, as it always has, as it always will. Gravity's patient hand continues to guide the cosmic choreography, creating beauty and structure from chaos, weaving connections across the vast emptiness of space and reminding us that in a universe of unimaginable scale, everything is connected to everything else through invisible threads of gravitational influence. Sleep well, fellow cosmic dancer. The universe will keep spinning while you rest, held together by the gentle, persistent embrace of gravity's eternal ballet. Sweet dreams, and may they be filled with the wonder of our place in this magnificent, ever-dancing cosmos.